grade 12, still busy with exercise 9.3. We're going on to question 7 now. Okay, so from here, what it's saying is the sketch represents the graph of a cubic function y is equal to f of x. Now we're not actually given the function, they just told us that it's a cubic, and it passes through the origin. So we know it passes through the origin over here. Okay. The turning points are at B, which is over here, and it has C0 as its coordinate, A over there, which is the coordinate AB, and then we have that C, which is DE over here, is your point of inflection, and it has the coordinate DE. Determine the values of x in each of the following situations in terms of A, B, C, D, and E, where f of x is less than 0. So if we're talking about f of x is exactly the same as talking about the y values. Okay, so in this case here, we're talking about f of x less than 0. In other words, where are the y values negative? So if we have a look here, we can see that the y values, if this is our y-axis here, so our y values over here are all negative down here, and our y values above here are all positive. So if the graph is above the x-axis, all the y values will be positive, and if the graph is below the x-axis, all the y values will be negative. So you can see that the graph is negative over here, over here, over there, over here, and over here. Our y values are 0. Okay, then once you get past here, our y values are positive. So we're looking for where it is negative. So as you can see here, x is going to be less than 0. Okay, so for all x values less than 0, you can see our graph is below the x-axis. But this point over here is on the x-axis, and our y value becomes 0. And we're not interested in that because it's strictly less than 0. So we must just add in here that x cannot be equal to this x value over there, which is c. And it cannot be equal to that. All right. So anywhere along here, it will be negative, except for that point over there. Now, question B is asking, where is f dash x less than 0? So if we look at question B, they're saying, where is f dash x less than 0? This actually means, where is the gradient of the graph less than 0? So if a gradient is negative, it means that the graph is going in this direction. Okay, and I just want to show you here in a different color. If m was positive, in other words, if our gradient is positive, our graph is going in that direction. So we're looking for where's the graph going in that direction. And you can see that it's going in that direction from here to there. Over here, it's going in that direction. From this point onwards, it's going in that direction. So over here, it has a negative gradient from there all the way up to here. Our gradient over there is 0 because it's a turning point, and our gradient over here is 0 because that's also a turning point. So we're interested in between C and A. So for this, x will be less than A but greater than C. Okay, another way of writing that is we can say x is an element from C to A, both exclusive. All right, question C. The graph is concave up. Now remember, question C, concave up is in that direction, so we can say concave up, and in that direction it's concave down. Okay, and just remember that it starts at your point of inflection and goes on. So this thing will start or end at your point of inflection. So we're looking for where it is concave up, in other words, in this direction. So it's going to start at our point of inflection and it's going to carry on. So from there to there, it's concave up. If we look at it concave down, it would be from here and it would end at our point of inflection. So for concave up, x must be greater than that d value, okay? Because everything along here is concave up, so it's everything on that side. So x is greater than that d value at our point of inflection. Okay, if we look at the next one, question D, they're asking f dashed x times f double dashed x greater than 0. Okay, so before I answer this question, I just want to show you how we would get something like this. Something times something greater than 0. The only way we could get that is if it's a positive times a positive, that would be greater than 0, or a negative times a negative would be greater than 0. So we're looking for where f dashed and f double dashed is positive at the same time. And the other one we're looking for is where f dashed is negative and f double dashed is also negative. So if I have a look at the f dashed, remember that's talking about your gradient. So all along here our gradient is positive, there it's negative, then onwards from here it would be positive. Okay, the gradient is positive there. So let's look at this case here. I'm looking at this first case here where they're both positive. Now remember, this is when our graph is going to be going in that direction. This is when they're both positive in that direction. For this one to be positive, it must be concave up. Okay, so we're looking for where we have a positive gradient and our graph is concave up. Well, the graph is concave up from that point of inflection and onwards, but you can see here our gradient is negative. So we're not interested in that bit, but our graph from this point is onwards is still concave up, but now we've got a positive gradient. So we are interested in that point over there. So it's going to be x greater than a. It's the one bit. So for this one here, x is greater than a, where it's positive and concave up. Now I'm going to look at where they're both negative. Okay, so for this one to be negative, our graph needs to be going in that direction. And for our second derivative to negative, we're looking at where it's concave down. So for concave down, it's over here, up to our point of inflection. But we are not interested in this bit here because this is where our gradient is positive. We need our gradient to be negative. And you can see our gradient is negative from C up to D. So our second part here would be x is greater than C but less than D. So greater than C but less than D. Another way of writing this is we can say x is an element from C to D, both exclusive. So it's that bit and this bit or this bit. These mean the same thing. All right, grade 12s, and that's it for question 7.